Welcome back, Math 9. Today we are continuing our distribution of polynomial, which is, when it comes to bad math, it is actually bracket and multiplication situation. One thing that we learned last time is basically how can we deal with any type of constant, which is monomial, multiplying with any type of polynomial using algebra tiles. And as you may notice at that time, it can be quite tedious. What I mean by tedious is, well, algebra tile takes a long time to construct. And some of the rule, like for example, if you have negative number outside, but the inside, what should I do? Then you need to double think. Like, should I change the empty one to colored one or filled one change into color empty one, something like that. You need to apply several changes. So today's method basically introduce you mental math skills. And when I say mental math is algebraic method, you can think it in that way. And when it comes to algebraic method, know the fact that we have to use distribute property method, which is how can you expand properly? Consider that as expansion skill by distributing. It's a combination of those two. Let's look at generic rule, ladies and gentlemen. Imagine you have monomial A. It can be 5x, 6y, or it can be 5x squared, those kind of things. But today we're going to look at constants. So think about any type of integers. Other than zeros. Even though 0 works too, but not a lot of people multiply 0 at the end. A, and then bracket you have either adding or subtracting, which is binomial in this case, because adding and subtracting kind of separate the group over here. Then here's what happened. As you may notice, if you have no sign specifically, then that means it's multiplication. So that means you're multiplying A to each of these corresponding binomial. It can be trinomial or it can be multiple type of polynomials. But in any case, once you distribute, then A and B multiply, so it turned out to be AB. A and C multiply, AC. So A bracket B plus C is equivalent as AB plus AC. Similar thing will happen in subtraction. The only thing that differ between the first and second is basically the sign in between those two terms. So without further ado, if you look at generic expression, it's sometimes even tougher. Let's go straightly to the example. Actual example. 2 and then bracket open x plus 3. As you may notice, 2 is my whole number. Technically, it's part of an integer. Whole number is, I mean. So you're expanding and distributing this whole number or any integer to each members of the polynomial. So you will have 2 times x plus 2 times 3. That is what happened, which is 2x plus 2 times 3 is 6. Like that. At this point, you may notice, wow, what's the point of knowing the algebra tile rule? Well, trust me, it's going to come back again when it comes to grade 10, just for the heads up. Let's look at each of the example. As you may notice, like I mentioned, you have monomial, polynomial, monomial, polynomial, monopoly situation. And we're going to do some advanced question at the back too. One thing that you need to understand is when it comes to distribution, always go descending order too, or in this case, left to right. I know it's tedious, but I want you to write down the whole process. As you may notice, I'm multiplying not the sign, but just a number. So 2x squared, or single term, The next one is by itself too. So 2x squared minus 2. That's how you do. You don't need to have tiles, even though it's gonna reintroduce again though. Same thing. It's multiplication that you should have for each of these guys. So negative 3 times x plus negative 3 times 1. So you technically have negative 3x plus negative 3, which is negative 3x. And you can simply put minus 3. Today's lesson is quite simple. It's actually going to be a quick lesson. Then you will have negative 2x. Oops, negative, yeah, we can just do it at once for this. Minus negative 2 times 2. Then you have negative 2x minus minus 4, which gives me negative 2 plus 4. Always double check. Negative and positive should give me negative answer. Negative and negative should give me positive answer. Two times x squared plus 2 times 3x. Give me 2x squared plus 6x. Everything was positive. Good to go. 5 times 3x squared plus 5 times x plus, minus 5 times 7. I sometimes keep the sign the way that it is to make my life easier. That's what I have. 15x squared plus 5x minus 35. I know I went through everything quite quickly, so I hope you guys put a pause button for some examples to make your life a little bit easier. When it comes to your booklet, page 16 is the only to-do list that I put because, and I want you to prepare a blank pieces of paper because we are going to do some advanced question over here. At this point, I want you to pause the video and then copy A, B, and C. Right now, I don't think you can see C. There are 3 questions. I want you to copy these 2 first. Once that's done, let's go through these. I put a little advanced question because here's the thing. When it comes to monomial, what you see over here, negative 3m, these are example of monomial. In this case, sorry, it's a singular, monomial. Monomial is a fancy way of saying you only have one term. In this case, negative 3m. In previous examples, you had whole numbers and integers, which is also monomial because you only have that single countable numbers. So in that situation, what are you going to do if you have your symbol, in this case variable, m? And what are you going to do if it doesn't overlap? Don't get panicked because here's the thing. We're doing exactly the same thing. So we're going to put bracket open, negative 3m multiplied by 4n plus negative 3m multiplied by positive 2. But here's the thing. I am going to look at these expressions quite in detail. What I mean by that is, if you look at it, do you agree that it's 3m, negative 3m is equal to negative 3 multiplied by m? Positive 4n is a fancy way of saying multiply by positive 4 and multiply by n. Same thing. I want you to do this for the second term. Because if you do this, you will figure out that the only numbers that I can actually multiply are the whole numbers and integers. And when it comes to letter m and n, you just put them together. If, however, this is assuming n and n, then you will have n squared. But we are not having a same same variable situation, don't we? So in that case, 4 times negative 3, that's negative 12, and you go alphabetical order. L, M, N, O, P. Wait, L, M, N, O, P. There you go. M and N. Oof. So it is descending order, right? When it comes to alphabet, negative 3 times positive 2 give you negative 6. M. There you go. That's how we do. Some people basically get panicked or getting into dilemma because you have a different type of variable. But if it's different type of variable, who cares? It's multiplying together. We just omit the sign of multiplication. We don't put n times n when we simplify. So we just put them up and line up. Know the fact that when it comes to these guys though, like I mentioned, alphabetical order is what I want to point it out to you. Let's do the second example, folks. We have negative 12m as outside, and we're trying to distribute what's inside. And I know I put a very ugly way, but it's 4mn, by the way, equal to. Do the same thing. Bracket open, negative 12 times n, negative 5 times n, plus negative 12 times n times 4 times n times n. This is where things are getting a little tricky because, first thing first, we can combine negative 12 and negative 5. We can multiply them. Good. But can you see that m and other m, this is same kind. So if I rewrite the whole expression for the first one, first of all, 12 times 5, that's 60, and negative turning into positive, so 60. And m times m is repeated twice, m squared. You can put it in this way. Other part, negative 12 and 4, I can combine. M and m, I can combine. When it comes to n, is single out, so the second expression will be a little bit funky. Negative 12 times 4 is negative 48. M and m become m squared and followed by. This is how you express your polynomial multiplication using distribution method. Know the fact that when it comes to these guys still, it is alphabetical order. There you go. Same thing. I want you to, let me just, that's better position. Now we have monomial 2x. And we have bunch of letters, and which is variables, more than ones, and we have a whole number. Long story short, who care about the whole different type of arrangement? We just need to multiply these two, and these two. I know it's tedious, but it's a good idea to write down the whole thing. 2 times x times 2 times a times b minus 2 times x times 2 times x times y plus, because that's a sign, 2 times x times is 3. I want you to figure out what pairs work or can be combined. 2 and 2. X, A, B, they're exact different. Type of variable, 2 and 2, what do you know? X and X, and 2 and 3, X stays the same. So 2 times 2, that's 4, and alphabetical order ABX, minus 2 times 2, that's 4, x times x, that's x squared. Then you have single out y plus 2 times 3, that's 6x. So ladies and gentlemen, we have our final answer, 4abx squared minus 4x squared y plus 6x. Technically, when it comes to degree, we're going to learn that this is a little bit of math 10 situation. Can you see that there's a square and there's nothing? Sometimes people put this other way around, highest degree, but you will know there's a square and 1 exponent, so that's 3. That's 1, 1, 1, that's 3. So you will learn about the complex degree system when it comes to polynomial in next grade, not in grade 9 situation. But that is today's lesson. You're going to see the video clip right after this that show you the textbook questions that you're going to work on.